Good afternoon, students. Are you able to hear my voice? Okay. So, did my screen is visible?
Yes, ma'am.
Okay, guys. I informed that on 17th, everyone should submit the assignment from Unit 1 and Unit 2. Where is the assignment? Only one person, Vinutna, has submitted the assignment. What about remaining? Don't you need marks? I think you know that for assignment also you have marks, right? And these marks will include in the mid exam. Depends on your date of submission, your marks are going to reduce. Do remember that. So, okay, coming to the second unit. So, the second unit last topic is nothing but the Bernoulli's equation, right? So, of course, we know that this Bernoulli's equation can be obtained from Euler's equation. So, Euler's equation is the sum of all pressure forces which were acting on it. And based on that, we can get the Euler's equation as dp by rho plus g into dz plus v into dv is 0. And by integrating this Euler's equation, we can get the Bernoulli's equation. And by integrating the equation, the Bernoulli's equation will be like P by rho z plus V square by 2z plus Z equals to constant. And here P by rho z is the pressure head or pressure energy, and V square by 2z is the kinetic energy or velocity head, and Z is the potential energy or datum head. So this term says that the Bernoulli's equation statement is nothing but the total energy acting at different points is constant throughout the flow. So if we take a pipe and in that pipe, if you take a pipe and in that pipe, if we take different sections and in that sections, if we measure the total energy, then the total energy will be constant at each and every section. So that statement is nothing but the Bernoulli's equation. So based on the Bernoulli's equation, we can calculate the total energy or the total head. And this Bernoulli's equation is the very, very important equation to design the machines or to design the devices. So what we are conducting in laboratory. So in the laboratory we have so many equipments, isn't it? Like impact of jet and vanes, and then venturimeter or phase meter, sudden contraction, pipe friction, then small orifice, mouthpiece, triangular notch, rectangular notch, then hydraulic jump, even the pumps and the turbines. So each and every machine, all the machines are simply depends on the principle of Bernoulli's equation only. If we know this Bernoulli's equation, then only it is easy to design the devices like a venturimeter or orifice meter or so on. So up to the second unit, we have discussed about these Bernoulli's equations, right? And in the third unit, let's discuss about the devices which are work by using this Bernoulli's equation. So based on the Bernoulli's equation, based on the Bernoulli's principle itself, the machines are going to design with different discharges, different pressures, and so on. So let's look at on a first device, that is venturimeter. So these are the practical applications of Bernoulli's equation. So the Bernoulli's equation may be applicable for the incompressible fluid flows, for the steady flows, and for the uniform flows, isn't it? And also irrotational flows. So based on that principle only, we can design the venturimeter or orifice meter or even the pitot tube. So coming to the first device, venturimeter, you know that venturimeter. What is the use of venturimeter? This machine is used to measure the coefficient of discharge or to used to measure the discharge which was flowing through a pipe. Suppose if the input of the pipe, inlet of the pipe and outlet of the pipe discharges same amount of water, then we can say there is no head loss per second, and that can be found out by fixing this venturimeter. So to fix this venturimeter, we should know what are the different parts, and we should know the design procedure, and also we should know the expressions for rate of flow through the venturimeter. So let's discuss about the venturimeter. So venturimeter is a device and it is having three parts. The main one is a short converging part, and the second one, so this is a short converging part, and the second one throat, and then the third one is divergent part. You can see this is convergent, a short one, convergent part, and the middle one, this portion is throat, and then this portion is divergent. So always at the inlet we can get the convergent, and at the outlet we can face divergent part. Okay, so these are the main parts of venturimeter. The convergent inlet, convergent, middle one throat, and then the outlet divergent. Right? Convergent, convergent, throat, and then divergent. Always at the inlet we can see the convergent, and it is the shortest one, and at the outlet we can see the divergent, and that was a largest one. Okay, so now to derive the expression for rate of flow, to derive the expression for discharge, so let's take two sections. One second. So consider at the inlet, this is the first section, and at the throat, consider this is the second section, and insert two pitot tubes or two piezometers at the inlet at the section 1, and at the throat, that is at the section 2. So this is the piezometer which was inserted at the section 1, and this is the piezometer which was inserted at the section 2. And the pressure difference between these two meters will be H. The pressure head difference, H, the head difference between these two piezometers will be H, and the diameter at the inlet is D1, and the diameter at the throat is D2. So we know that, right? So consider this section 1. At the section 1, D1 is the diameter at the inlet or at section 1, and P1 is the pressure at section 1, and V1 is the velocity at section 1. And also the area at the inlet A1 can be calculated by using the formula. We know that pi d1 square by 4. So everything you know, isn't it? So మీరు ఆల్రెడీ వెంచరోమీటర్ ఎక్స్పెరిమెంట్ చేశారు కాబట్టి మీకు ఈ వాల్యూస్ అన్ని ఐడియా ఉంటుంది, d1 area and the discharge, right? And similarly d2 is the diameter at the section 2, that is at the throat. p2 is the pressure at section 2, and v2 is the velocity of the fluid at throat, and a2 is the area at the throat, that is pi d2 square by 4. So now let's apply the Bernoulli's equation at the section 1 and at the section 2. So what is the Bernoulli's equation? We know that the Bernoulli's equation is nothing but sum of all heads or sum of all energies, that is P by rho z plus V square by 2z plus Z is constant. And applying this equation at section 1 and 2, then the equation will be P1 by rho z, that is at the section 1, plus V1 square by 2z plus Z1 is equals to P2 by rho z plus V2 square by 2z plus Z2. So here the pipe is horizontal, isn't it? The pipe is not at different levels, isn't it? So that the datum heads at section 1 and at section 2 are equal, isn't it? The pipe is, this venturimeter is at horizontal level, so that the datum head at section 1 and at section 2 will be equal, that is Z1 is equals to Z2. Suppose if the pipe is not horizontal one, or if the pipe is an inclined one, in that case the datum head will be vary from section 1 to section 2. But in this case the pipe is horizontal, so that the datum head at section 1 and section 2 will be equal, that is Z1 is equals to Z2. Then this equation will become as P1 by rho z, Z1 and Z2 will be cancelled or maybe taken as 0. Then this equation become as P1 by rho z plus V1 square by 2z is equals to P2 by rho z plus V2 square by 2z. So, and also we can take pressures in left side and velocities in the right side. Then this equation will become as P1 minus P2 by rho z. So P2 by rho z left side వెళ్ళింది. Then P1 minus P2 by rho z is equals to V2 square by 2z minus V1 square by 2z. So we know that P1 minus P2 by rho z is nothing but pressure heads, the difference of pressure head at section 1 and 2. So that's what we can we have seen in the figure. This one here, what is H? H is nothing but pressure head difference between two piezometers, isn't it? H here, H is nothing but pressure head difference between two piezometers. So this is H, right? So H is nothing but the pressure head difference between the two piezometers, right? So from this we can write P1 minus P2 by rho z is nothing but the difference of pressure heads at section 1 and 2, so that this value will be equals to H. So we can write P1 minus P2 by rho z is equals to H, and then substituting the value of H in this equation, then we get P1 minus P2 by rho z is equals to H. So this equation will become as H is equals to V2 square by 2z minus V1 square by 2z. So simple గా ఈ ప్లేస్ లో P1 minus P2 by rho z ప్లేస్ లో H సబ్స్టిట్యూట్ చేసాం. దట్స్ ఇట్, రైట్? సో P1 minus P2 by rho z ప్లేస్ లో H ని సబ్స్టిట్యూట్ చేసాం. దెన్ వి గెట్ H ఈక్వల్స్ టు V2 square by 2z minus V1 square by 2z. Now take the continuity equation. So what is continuity equation? A1 V1 is equals to A2 V2. Isn't it? Continuity equation is nothing but A1 V1 is equals to A2 V2. Isn't it? So from this continuity equation, we know that, right? For one-dimensional flow, the continuity equation will be A1 V1 is equals to A2 V2. So from this equation, we can write the velocity at section 1 V1 is equals to A2 into V2 by A1. Isn't it? A1 V1 equals to A2 V2. From this, V1 will be equals to A2 into V2 by A1. So substituting this value of V1 in this pressure head equation, that is H equals to V2 square by 2z minus V1 square by 2z. So instead of V1, we can substitute A2 V2 by A1. So substituting that value, then the equation will be H equals to similarly V2 square by 2z minus V1 place lo deni substitute చేస్తున్నాం A2 V2 by A1. So it will be V2 square by 2z minus A2 V2 by A1 whole square by 2z. And of course, we can take from this equation, we can take V2 square by 2z as common, isn't it? So here also we have V2 square by 2z, and here also we have V2 square by 2z. And by taking V2 square by 2z as common, then the equation will be V2 square by 2z into 1 minus A2 square by A1 square. And also we can write it as V2 square by 2z into A1 square minus A2 square by A1 square by taking A1 square as LCM. So, and so here the equation will be H is equals to V2 square by 2z into A1 square minus A2 square by A1 square. And from this equation, the value V2 square by 2z, V2 square can be written as V2 square is equals to 2gh. So 2z left side వెళ్తుంది, isn't it? Then it will be 2gh, then 2gh into, it will comes to numerator, then it will be 2gh into A1 square by A1 square minus A2 square. So do you understand the derivation? Derivation అర్థమవుతుందా? So continuity equation తీసుకున్నాం, A1 V1 equals to A2 V2. Continuity equation నుంచి the velocity at section 1 can be taken as A2 V2 by A1, and substituting this velocity at section 1 in the pressure head difference, that is H equals to V2 square by 2z minus V1 square by 2z equation, and simplifying this, finally we get H equals to V2 square by 2z into A1 square minus A2 square by A1 square. V2 square by 2z into A1 square minus A2 square by A1 square. And from this equation, let's take the velocity head at section 2, that is V2 square is equals to 2z into h. Forgot this, then this will be v2 square is equals to 2z into h into a1 square by a1 square minus a2 square, and from there v2 will be square root of, so applying the square on both sides, so we get v2 equals to square root of 2zh into a1 square by a1 square minus a2 square, and simplifying this we get a1 by root of a1 square minus a2 square into square root of 2zh, and we know that the discharge is nothing but q is equals to a2 v2 at section 2. The discharge is nothing but a2 into v2. The discharge at the outlet will be a2 into v2. Then the substituting v2 value, substituting v2 value, that is v2 is equals to a1 by square root of a1 square minus a2 square into root 2zh. Substituting this value in the place of v2, then we get a2 into a1 by root a1 square minus a2 square into root 2zh, and this equation finally become as a1 into a2 by square root of a1 square minus a2 square into root 2zh, isn't it? So this is the discharge equation, and this discharge is known as the theoretical discharge. This equation is known as the theoretical discharge. So we know that already we have conducted an experiment on venturimeter. So from that already you know the equation for theoretical discharge. What is the equation? Q equals to Q theoretical equals to a1 a2 by root a1 square minus a2 square into root 2zh. And using this theoretical discharge, we can calculate the actual discharge by knowing the coefficient of discharge. Then it will be actual discharge equals to, what is coefficient of discharge? Actual discharge by theoretical discharge, right? From there actual will be coefficient of discharge into theoretical discharge, isn't it? So these are the equations for theoretical discharge and actual discharge, and usually the coefficient of discharge for venturimeter will be is always less than 1, or even this value may be in between 0.98 to 0.99 only. The coefficient of discharge value for the venturimeter is 0.98 to 0.99 only, right? So using the Bernoulli's equation, we can get the rate of flow, we can get the discharge equation like this. So what we did, so what we did is simply we have taken a venturimeter. In that venturimeter, we have inserted two piezometers, and one is at the section 1, that is at the inlet convergent part, and another one is at the middle, that is at the throat. And we considered that one as the section 2, and we have considered the pressure head difference between the two piezometers will be h. The pressure head difference between two piezometers will be h, and we consider the diameter at section 1 is d1, pressure flowing through the pressure of water flowing through the section 1 is a p1, and velocity which was flowing through the section 1 is v1, and the area can be calculated as a1 is equals to pi d1 square by 4, and similarly diameter d2, pressure p2, velocity v2, and the area a2 at section 2. And now we have applied the Bernoulli's equation on the both sections. So by applying the Bernoulli's equation on the both sections, we get p1 by rho z. The equation will be p1 by rho z plus v1 square by 2z plus z1 is equals to p2 by rho z plus v2 square by 2z plus z2. And here the pipe is horizontal, so it was not at individual intervals, so that the datum heads at section 1 and section 2 will be equal, that is z1 is equals to z2. Then this Bernoulli's equation will become as p1 by rho z plus v1 square by 2z is equals to p2 by rho z plus v2 square by 2z. And we can also write this equation in terms of pressures and velocities as, then this equation become as p1 by p1 minus p2 by rho z is equals to v2 square by 2z minus v1 square by 2z. And we know that p1 minus p2 by rho z is nothing but pressure head difference between two sections, right? P1 minus P2 by rho z is nothing but the pressure head difference between two sections, and this is equals to H. That's what we have taken in the figure, isn't it? So this is equals to H. So this equation will become as H is equals to V2 square by 2z minus V1 square by 2z. Now let's take the continuity equation. So what is continuity equation? A1 V1 equals to A2 V2. And from this, V1 will be equals to A2 into V2 by A1. So let's substitute the velocity at section 1 on the pressure head difference equation. Then the equation will be H equals to V2 square by 2z minus, instead of V1 we have substitute A2 V2 by A1 whole square by 2z. And then by simplifying this equation, we can get the equation for velocity, that is velocity at section 2, that is V2 is equals to square root of 2zh into A1 square by A1 square minus A2 square. And also we can simplify further this equation as by so we can simplify this equation as a1 by square root of a1 square minus a2 square into root 2zh, right? And the discharge at outlet can be calculated as the discharge at outlet q equals to a2 into v2. Outlet are nothing but the throat at section 2 only. So water inlet నుంచి అవుట్లెట్ కి థ్రోట్ ద్వారానే కదా ఫ్లో అవుతుంది. సో మనం క్యాలిక్యులేట్ చేసింది కూడా థ్రోట్ దగ్గరే. సో దట్ we can consider the throat as the outlet. Then the discharge will be q equals to a2 into v2 at the outlet, and substituting the velocity at section 2 in this equation, then we get the discharge is equals to a1 a2 into root 2zh by root of a1 square minus a2 square. And this discharge is known as the theoretical discharge. This discharge is known as theoretical discharge, and using this discharge we can calculate the actual discharge as actual discharge equals to coefficient of discharge into theoretical discharge. What is the formula for theoretical discharge? That is a1 a2 by root of a1 square minus a2 square into square root of 2gh. Okay, that is the equation for actual discharge and theoretical discharge, right? And we should remember that the coefficient of discharge of venturimeter should be always less than 1. That means the value may be ranges between 0.98 to 0.99 only. Okay, so that is the derivation for that is the expression for rate of flow by using the venturimeter. A very important one. You have to remember a very important derivation for the venturimeter, even for the exams also. Okay, so now let's calculate the value of H. So what is H here? H is nothing but pressure head difference between two sections, isn't it? H is nothing but the pressure head difference between two sections. Suppose if we use a YouTube manometer to calculate the pressure head difference between two sections, and in a YouTube manometer we can take two liquids. One is the heavier liquid and the another one is a light liquid. The heavier liquid is nothing but usually we will take the mercury, right? So let's consider S suffix H as the specific gravity of heavier liquid and S suffix O as the specific gravity of the liquid which was flowing through the pipe. And consider X is the difference of heavier liquid column in the YouTube. So the difference, that is H1 minus H2. So reading in the left limb but reading in the right limb, the difference will be X, H1 minus H2. So now the value of H can be calculated as X into SH minus SO minus SH by SO minus 1. Here X is the difference of the heavier liquid column in the YouTube, that is H1 minus H2, and SH is specific gravity of heavy liquid, and SO is the specific gravity of liquid which was flowing through the pipe, right? So like this we can calculate the value for H. And suppose if we need to calculate another case, so if suppose if the manometer contains the liquid lighter than the liquid which was flowing through the pipe, just like the manometer is having the petrol and even petrol oil and the water which was flowing through the pipe. So in this case, if the heavy liquid is water and the lighter liquid is petrol, and in that case, the H value can be calculated by using the formula H equals to X into 1 minus of SL by SO. Here SL is the lighter liquid in the tube which was flowing through, and SO is the specific gravity of the fluid which was flowing through the pipe. Okay, so that is about the head and discharge of a venturimeter. The equation for head is H equals to X into SH minus SH by SO minus 1, and here X is the difference of liquids in the tube, that is H1 minus H2, and the theoretical discharge equation will be A1 A2 into root 2ZH by root of A1 square minus A2 square, and here the actual discharge is coefficient of discharge into the theoretical discharge. Right, so these are the equations for actual discharge and theoretical discharge. And suppose in case of the inclined venturimeter, suppose if the venturimeter is in inclined position, like this. Suppose if the venturimeter is in inclined position, this is the inlet and the convergent, and this is throat. This is convergent, the shortest one, and this is throat, and this is divergent for the inclined venturimeter. And here also we are going to insert two piezometers at the section 1 and at the section 2, that is at the inlet and at the throat, and by applying the Bernoulli's equation we can get the same equation, same as the normal type of venturimeter. But what is the difference is, in this case the datum headed section 1 and datum headed section 2 will be different. So this is at certain level and this is at another level, isn't it? The inlet is at higher level and outlet, the throat is at lower level. So that definitely we may get some datum heads. The Z1 and Z2 values will be exist in case of inclined venturimeter. So in this case, the value of H can be calculated as H equals to P1 by rho z plus Z1 minus P2 by rho z plus Z2. Do you understand? ఇక్కడ ఏం చేసాం, హెచ్ అంటే ఏంటి, జస్ట్ P1 minus P2 by rho z మాత్రమే. Why? Because Z1 and Z2 will get cancel. Z1 and Z2 will get cancel, isn't it? So why? Because here the pipe is horizontal, so the section 1 and section 2 are at the same levels. But in case of the inclined venturimeter, the Z1 is at a higher level and Z2 is at lower level. So both will exist. And in this case, the pressure head can be calculated by including the datum heads also. So that the difference of pressure head in between two sections will be P1 by rho z plus Z1 minus P2 by rho z plus Z2. Same like the before equation. సో ఆ ఈక్వేషన్ లో ఏంటంటే Z1 అండ్ Z2 క్యాన్సిల్ అయిందంటే, ఇక్కడ క్యాన్సిల్ అవ్వకుండా ఈ వాల్యూస్ కూడా ఎగ్జిస్ట్ అవుతున్నాయి. దట్స్ ఇట్, దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ బోత్ టూ, రైట్? సో ఫర్ inclined venturimeter also, the equations like theoretical discharge and coefficient of discharge and actual discharge equations will be same. What's the difference is, in this case the H value can be taken as P1 by rho z plus Z1 minus P2 by rho z plus Z2. So here the Z1 and Z2 values will also include. Okay, so that is the difference between normal type of venturimeter and inclined venturimeter. Okay, so let's discuss a problem on the venturimeter, the horizontal venturimeter. I'm reading the problem, so listen it carefully. The problem is a horizontal venturimeter with inlet and throat diameters 30 centimeters and 15 centimeters respectively, right? So what they given, the horizontal venturimeter, okay, and is used to measure the flow of water. and the reading of differential manometer connected to the inlet and throat is 20 centimeters of mercury. 20 centimeters of mercury. Determine the rate of flow. Take the coefficient of discharge CD as 0.98. Right. So problem name icharu. The problem is given for the horizontal venturimeter. So for the horizontal venturimeter, the inlet diameter, inlet ante convergent. At the convergent, the diameter is 30 centimeters, and at the throat, the diameter is 15 centimeters. At the inlet, the diameter 30 centimeters, and at the throat, the diameter is 15 centimeters. D1 is 30 centimeters, so we should convert the value into meters. Always do remember. And D2 is 15 centimeters, right? And next, what is the given? The reading of differential manometer connected to the inlet and at the throat is given as 20 centimeters of mercury. So differential manometer lo reading ante direct ga manometer difference ichadu. Manometer difference ante with the value of x. X is nothing but h1 minus h2. So directly h1 minus h1 minus h2 value entundo ichesadu, that is x equal to 20 centimeters of mercury in terms of mercury. So using these values, what we should calculate? We should calculate the rate of flow, that is the discharge, theoretical discharge as well as the actual discharge. And also they have given the coefficient of discharge as 0.98. So let's write the given data. The given data is diameter at the inlet D1 is 30 centimeters, and for that the area can be calculated A1 as pi by 4 into D1 square, pi D1 square by 4. So substituting the value, we can get the area as 706.85 centimeters square. And then D2 is given as 15 centimeters. Then it will be A2. Then the area will be A2 equals to pi by 4 into 15 square. Then the value is 176.7 centimeters square. And the another data, CD is given as 0.98, and the difference in the manometer is given as x equals to 20 centimeters of mercury. They have given in terms of mercury, but we should calculate the discharge for flow of water. They have given, which is used to measure the flow of water. Water అని మెన్షన్ చేశాడు, isn't it? But వాడు ఇచ్చిన value in terms of mercury. So here we should convert the value of mercury into water. One second, guys. So here they are given the value in terms of mercury, and to convert the value from mercury to water, we are going to multiply the value by using the specific gravities of mercury and the specific gravities of water. So that to calculate the head of water which is flowing through the pipe, we have the formula, that is H equals to X. X is nothing but the difference of the mercury levels, that is H1 minus H2 into SH by SO minus 1. Here SH is specific gravity of heavy liquid and SO is specific gravity of the liquid which was flowing through pipe. So specific gravity of heavy liquid. Ikkada heavy liquid em ichadu? Mercury. For the mercury, the specific gravity is 13.6. For mercury, the specific gravity is 13.6, and SO is nothing but specific gravity of the flowing liquid. Ikkada flowing liquid em ichadu problem lo? Water added, isn't it? So specific gravity of water is 1. Now substitute the value to calculate the H, then it will be H equals to X. X value is 20 centimeters of mercury. Differential manometer reading is given as 20 centimeters and the difference is already. H1 minus H2 is given as 20 into 13.6 is the mercury specific gravity and 1 is the water specific gravity. Substituting the values in this formula, we can get the head value as H equals to 252.0 centimeters of water. So in terms of mercury ni manamu water lo convert cheyali ante we have to multiply the value with specific gravities. Okay, using this formula only we can convert the value of specific gravity, we can convert the values of mercury into water. Suppose అదే mercury and oil ఉందనుకోండి, then the equation will be 13.6 by oil ki specific gravity 0.7 అయితే it will be 0.7 minus 1. అదే value water and oil ఉందనుకోండి, then it will be 1 by 0.7 minus 1, isn't it? సో లైక్ దట్ మనకి ఏ లిక్విడ్ ఇచ్చాడో దాన్ని బేస్ చేసుకుని ఈ వాల్యూ చేంజ్ అవుతూ ఉంటుంది. సో 20 సెంటీమీటర్స్ ఆఫ్ మెర్క్యూరీ అన్నాడు కాబట్టి మెర్క్యూరీ తీసుకున్నాం. 20 సెంటీమీటర్స్ ఆఫ్ 20 centimeters of grease or 20 centimeters of tar, so and so. So ilanti values iste we should take the specific gravity of higher liquid and the heavier liquid and the specific gravity of the liquid which was flowing through the pipe, and then we should calculate the head. Okay, ప్రాబ్లం క్లియర్గా చదివి అర్థం చేసుకుని ప్రాబ్లమ్ని సాల్వ్ చేయండి. ప్రాబ్లంలో ఏ లిక్విడ్ ఇచ్చాడు, ఏ లిక్విడ్కి క్యాలిక్యులేట్ చేయమన్నాడు, దాన్ని బేస్ చేసుకుని దాని స్పెసిఫిక్ గ్రావిటీ ఏంటో మెన్షన్ చేసి ప్రాబ్లమ్ సాల్వ్ చేయాల్సి ఉంటుంది, రైట్? సో దట్ ఈస్ ద వాల్యూ ఫర్ హెచ్, and the value we get it as 252 centimeters of water. And we know that the discharge which was flowing through the pipe, maybe the actual discharge is equals to CD into A1 A2 by root of A1 square minus A2 square into root 2ZH, isn't it? So this is the formula for actual discharge, and of course we can calculate the theoretical discharge also directly, but they have given the coefficient of discharge, so that let's calculate the actual discharge and the value. Actual discharge is equals to, what is the CD? 0.98, and A1 మనం calculate చేసాం. What is A1? 706.85, and A2 కూడా 176.7. Substituting the values in this formula and the head also we have calculated. The head value is given as 252 centimeters of water, right? So ఇక్కడ వీళ్ళు చూసారా 9.81 G value is taken as 9.81 అన్నాడు. So 9.81 G is nothing but 9.81 meter per second square. So we should convert all the values into meters. Don't substitute the values in terms of centimeters. Always convert all the values into meters and then substitute the values. Why? Because in the formula we have G, and the value of G is 9.81 meter per second square. This value is in terms of meters, so that we should substitute all the values in terms of meters only, but not in centimeters. Convert the values, substitute the values in terms of meters, and find out the value of actual discharge. Okay, so that we can get the value of discharge maybe like this, right? So do you understand, guys? Do you understand about this, how to solve the problem? So మనకి ఏరియాస్ ఇచ్చాడు, సో డయామీటర్స్ ఇచ్చాడు, డయామీటర్స్ బేస్ చేసుకొని ఏరియా క్యాలిక్యులేట్ చేసాం. దెన్ డిఫరెన్స్ ఆఫ్ ది మెర్క్యూరీ లెవెల్ అంటే H1 మైనస్ H2 డైరెక్ట్గా ఇచ్చేసాడు, దట్ ఈస్ ఎక్స్ ఇచ్చేసాడు. దెన్ సిడి వాల్యూ ఇచ్చాడు, దీన్ని బేస్ చేసుకుని డిశ్చార్జ్ క్యాలిక్యులేట్ చేయమన్నాడు. సో here to calculate the head of water which was flowing through the pipe, we are using the difference in the mercury levels, that is difference in the manometer levels, that is X into SH by SO minus 1, and using this value we can calculate the discharge as Q equals to CD into A1 A2 by root of A1 square minus A2 square into square root of 2GH. So we have all the values, and substituting the values we can get the value for discharge. Is it clear, guys, about this problem? మీకు ఇప్పటి వరకు చెప్పింది అర్థమైందా? The derivation of the venturimeter and the problem related to venturimeter. ఏదైనా డౌట్ ఉంటే అడగండి. అర్థమైందా, అర్థం కాలేదు? డెరివేషన్ అర్థమైందా, అర్థం అవ్వలేదా? గివ్ మీ రిప్లై. మీరు చెప్పేదాన్ని బట్టి నేను నెక్స్ట్ టాపిక్ వెళ్ళగలుగుతాను. Why? Because it is through online. Okay, what about the problems? Is it clear?
Yes, ma'am.
Okay, then. So that is about the derivation and the problem related to the venturimeter. So let's discuss another problem of venturimeter. So in this problem they have given an oil. So they have given the oil. Here the oil is flowing through the venturimeter. So the flowing liquid is oil. The oil, for the oil they have given the specific gravity. So I'm reading the problem, listen carefully. An oil of specific gravity 0.8 is flowing through a venturimeter having inlet diameter 20 centimeters and throat diameter 10 centimeters. The oil mercury differential manometer shows a reading of 25 centimeters. Then calculate the discharge of oil through the horizontal venturimeter. Take CD is equals to 0.98. So problem name చెప్పారంటే the venturimeter is a horizontal venturimeter. So the given venturimeter is a horizontal venturimeter, and in that venturimeter the oil is flowing with a specific gravity of 0.8 అన్నారు. Okay, so flowing liquid ఏంటంటే oil and దాని specific gravity 0.8. Then the venturimeter inlet diameter at the convergent, the diameter is 20 centimeters, and at the throat, that is T2 is given as 10 centimeters. And they said that the oil mercury differential manometer. So manometer లో ఉండే heavy liquid mercury. వీడు ఇక్కడ చెప్పిన దాన్ని బట్టి manometer లో ఉండే heavy liquid ఏంటంటే mercury. And oil mercury differential manometer reading is given as 25 centimeters. So direct గా x value చేశాడు. The difference between both limbs H1 minus H2 is given as 25 centimeters. And they have given CD, coefficient of discharge, is given as 0.98. Using these values, what we should calculate? We should calculate the discharge. Right? So let's write the given data. So they are given that the specific gravity of oil as 0.8, and then the inlet diameter, the convergent diameter D1 is given as 20 centimeters. From that, the area can be calculated as A1 equals to 5 D1 square by 4, and D2 is given as 10 centimeters. At the throat, D2 is given as 10 centimeters. Always D1 is the bigger value and D2 is the smaller value. Do remember that. సో పెద్ద ఎక్కువ ఉండే వాల్యూస్ వచ్చి ఇన్లెట్ ఉంటుంది, అండ్ చిన్న వాల్యూ ఎందుకంటే థ్రోట్ చిన్నది కాబట్టి దాని డయామీటర్ చిన్నదిగానే ఉంటుంది. Then A2 can be calculated by using pi d2 square by 4, and they have given CD as 0.98. Using that, we should calculate the discharge. So to calculate the discharge, what is the formula? Q equals to CD into A1 A2 by root of A1 square minus A2 square into square root of 2GH, isn't it? So in this formula, we know the value for CD, we know the value for A1 and A2, but we should calculate the value for H, isn't it? So to calculate the value for H, we are going to use the formula, that is H equals to X into SH by SO minus 1. Here X is the difference in the manometers, the value of difference in the left limb and right limb, that is H1 minus H2. This value already given data lo undi. Then SH is the specific gravity of heavy liquid. So manometer lo heavy liquid em ichadu, mercury annadu, isn't it? Manometer lo heavy liquid mercury annadu. So the heavy liquid specific gravity is 13.6, as we know that the specific gravity of mercury is 13.6, and SO is nothing but the liquid which was flowing through the pipe. So pipe lo flow అవుతున్న లిక్విడ్ ఏంటి? వెంచరిమీటర్ లో ఫ్లో అవుతున్న లిక్విడ్ ఆయిల్, and the oil is having the specific gravity 0.8. So substitute the values SH as 13.6 and SO as 0.8, and X value is given as 25 centimeters, isn't it? So substituting those values, we can get the H value as 400 centimeters of oil. Why? Because the flowing liquid is oil only. So we have calculated in terms of the oil. So H value is 400 centimeters of oil. Now we have all the values. The value of CD, the value of A1, A2, and the value of H also. And we know the value for G, that is 9.8. So now we can substitute all the values, and you can see this value, the value of G is 981, and this value is in terms of meter per second, sorry, centimeter per second square, isn't it? 9.81 is meter per second square and 981 is centimeter per second square. So if you want to substitute all the values in terms of centimeters, then take the G value as take the G value as 981. So 981 is in the units of centimeter per second square. 9.81 is in meter per second square. So to convert the value into centimeters, we have to multiply with 10. Then we get, sorry, multiply with 100. 1 meter equals to 100 centimeters, right? So multiplying with the 100, we can get the value in terms of centimeter per second square as 981. So now substituting all the values in this formula, we can get the coefficient of discharge as 70465 centimeter cube per second. Okay guys, so is it clear about this? Centimeters lo substitute cheyalante take the G value as 981. Meters lo substitute cheyalante take the G value in term as 9.81. Right? So is it clear about this problem? But clear ga problem lo heavy liquid ఏమి ఇచ్చాడు, లైటర్ లిక్విడ్ ఏమి ఇచ్చాడు, దాని డిఫరెన్స్ ఎంత ఇచ్చాడు, దీన్ని చూడండి ఫస్ట్ ఆఫ్ ఆల్. అది చూసి తర్వాత ప్రాబ్లమ్ సాల్వ్ చేయండి. Based on that one only we can calculate the value of H. Here H ante the difference of the liquids multiplying with specific gravity of heavy liquid by specific gravity of the flowing liquid in the pipe. Specific gravity of the heavy liquid by specific gravity of the flowing liquid in the pipe. Okay, so using these values only we can calculate the head and discharges. Is it clear guys? So మీకు ఇక్కడ వరకు అర్థమైనా ఏదైనా డౌట్ ఉందా? ఐ నీడ్ ఆల్ ది రిప్లైస్. నాకు ఒకసారి అందరూ చెప్పండి, మీకు ఇది అర్థమవుతుందా, ఇలా ఎక్స్ప్లెయిన్ చేస్తుంటే ఏమైనా డౌట్ వస్తుందా? So derivation and the problems, is it clear?
Yes, ma'am.
Yes, madam.
మీకు ఎక్కడన్నా డౌట్ వస్తే, ఎక్కడన్నా అర్థం కాకపోయినా నన్ను ఆపేయండి. నన్ను ఆపి ఎక్స్ప్లెయిన్ చేయమని అడిగితే నేను మళ్ళీ కూడా ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే. And today onwards we have started third unit. The venturimeter, orifice-meter, all the topics are comes in third unit. Okay, and these are the follow-up of Bernoulli's equation. That's why again I have started the Bernoulli's equation and I have continued that Bernoulli's equation to derive the equation for venturimeter discharge. Okay guys, in the next class we will discuss the remaining. So if you have any doubts, ask me. I will explain twice or thrice or even 10 times also. What I need is everyone should understand the topic. That's what I need. So wait for a while. Let me take the attendance. Okay guys, in the next class we will discuss the remaining. You can leave.